Hi, this is Leo. This is my recording for the assignment 10. I'm going to uh, explain the model to my girlfriend Cici. She's she major in fintech, and she's also taking the machine learning for fintech courses. And she already has some background information about the machine learning. So I'm going to introduce this model to her. So this model is called rulefit model. So it's aimed to fit a sparse linear model on the rules extracted from the decision trees. So given a tabular data, like a data frame, already know the format. Like we have several rows and several columns. Columns are the features of data. So you can see for the normal path is the right path. The data uh, will be input into a regression model like lasso, and the features will be selected for the final interpretation, right? You're gonna make some weights of the features will be zero, so you can know what features is important. Um, but this model further integrate the features from decision trees. Those features called rule features. So let's recap some knowledge of the trees. So for the trees, how it make a decision, like make a prediction, like given data, it will split based on some criteria and draw the conclusion. Like when the weather is sunny and the time um the time like the time is not that long, we can take baths. So this is called a rule, like a pass from the tree model. So like weather is sunny and time is smaller than 30 minutes. So we can combine these features into the original features. Like it's a binary feature. Like for each data, if the weather is sunny and the time is smaller than 30 minutes, it's gonna be one or it will be zero. So we will add several columns to the original table. It's like banner features. So then will be input into Lasso for the final interpretation. The benefit of this step is that it can add more non-linear features because it non-linearly combine other features into the training process. So in such a case, it can be a good trade-off between the interpretation and accuracy. So do you have any questions or something you don't understand?
Yeah, I think you explained everything pretty clearly. So my only question is it kind of an innovative method or it had been like used for so many ways like in the academic or industry field before?
That's a good question. So in academia, I don't think this is widely used because academia is always building the new models for interpretation. And this is like a old method, but I really like the innovative idea of this model. For the industry, I believe they more focus on some existing very robust and mature methods like XGBoost or like GBM. So those are more powerful than this model. Yes. Any other questions?
Yeah, so have you ever like put it into the for example application to solve any um problem before, or you just like create the framework and you haven't like put it into the practice?
I never tried this in addressing some real world problems. Yeah, but this is pretty new to me. I never think about combining those two models for better interpretation and accuracy. And the best point that attracts me of this model is that it you it uses the rules from the ensemble models, and you have some knowledge of ensemble models, right? They combine multiple weight classifiers to achieve an unbiased model.
Yeah.
So, but the problem of ensembling model is that its interpretation ability is pretty bad because you assemble predictions from multiple models, and you know which rules they are utilized to form the final prediction.
Yeah.
So I think the model achieve a great trade-off between accuracy and interpretation. So do you have any questions?
No, thanks for introducing that.
Yeah, thanks. Bye.